Thank you everyone for being here. Thank you, Jamie, for being here. Are you feeling scrappy?
Yes.
Me too. Let's talk compost. Okay, so we're going to start this presentation with a game. The game is called compostable or not compostable. So what is compostable? Anything that was once alive and is now dead is compostable. So paper shreddings, that was once a tree. A banana peel, that was once a banana. Plants are alive. Fallen leaves, eggs, that would be the one exception. For some reason, those are compostable too, probably just because they're made of natural materials. And then coffee grounds, coffee was once a plant, and twigs and sticks. So pretty much anything that was once alive and is now dead is compostable. Okay, so think about that as we're going through the next few slides. You might get some tricks. Compostable or not compostable?
Compostable
What in the picture is not compostable?
are the stickers and the rubber band.
Yep. Compostable or not compostable?
Compostable.
Yes, logs, as long as you grind them, you put them in a chipper, they're compostable. How else might it be compostable? You've built one before in your yard. Hugelkultur.
Oh, Google culture.
Yeah, that's kind of like a type of compost pile, kind of.
Yeah.
Compostable or not compostable?
Compostable.
Why?
Well, it used to be alive
Yep,
because it's paper.
yep, there we go. What about the ketchup?
Ketchup also used to be alive.
Oh my gosh. Okay, compostable or not compostable?
The paper ones are compostable, the plastic ones are not.
Yep. Yeah, I composted one of the plastic ones recently and I found just the plastic part in my compost pile, but all the paper and the cotton is compostable. What about toothpicks?
Compostable.
Yep. What about these reusable bags?
The plastic one definitely is not. The ones made of, they're both, the one in the middle is made of fabric, that's compostable. It looks like the one on the Four Ocean one doesn't look compostable.
Yeah, the Four Ocean one, unfortunately, I think it might be made of recycled plastic. So that's cool, except for it's also going to end up in the ocean again. The one in the middle is made of cotton and linen. So canvas, if you tear it up in pieces, shred it or cut it with scissors, that can break down. And then the one on the right, that's a tarp. So you know that's plastic. And so all these are great to use because they're reusable bags. But the best one might be, in my opinion, the middle one. What about these wool socks or 100% cotton napkins?
Compostable.
Yay! They're natural products. Wool comes from a sheep or an alpaca usually. What about underwear? 100% cotton underwear.
Compostable.
Compostable. There's even a challenge. People see how good their compost is based on how fast their 100% cotton underwear can decompose. What about these bags, these plastic bags? They have a symbol on them. What's that?
Um, well, the one on the right is says it's compostable. The one on the left says eco-friendly. I don't think the one on the left is compostable. I think it's just recyclable or made of recycled something. Hard to see,
Yeah.
but the one on the right, I've seen those before, and they supposedly decompose. You can put your compost in them.
Yes. So if you see the label that says BPI certified, which you'll
Ah,
see, that means it meets California's standards so that it can be composted, but it's compostable in commercial compost facilities. So I think it has to reach a certain heat for a certain amount of time. I've tried composting ones and I'm still finding mine in my at-home compost bin. Microplastics. But that's at home, not commercial. So what about this one? Compostable or not compostable?
the box is compostable. The tape is not.
Yep. That was a good trick one. What about this?
Oil is
From your car engine.
uh seems like it used to be dinosaurs, so it was once alive. So I'm going to say compostable.
That's a good point. But would you put motor oil in your at-home bin?
I would not think that would be a good idea.
Oh, I think there might be heavy metals somewhere in that
For
car.
sure, additives probably.
So that one's a good question. What about dryer lint?
Should be if it's from cotton or anything like that, it should be compostable.
And if you wear all natural fibers, then you're okay. But if you wear polyester like me, then those will be plastic fibers. Weeds, compostable or not compostable?
Definitely compostable.
Yep. What about orange juice and milk?
Um, the orange juice and milk are compostable. The containers are not.
Nice. Yeah. Orange juice will really stimulate bacterial growth. What about candy? Skittles.
Seems like it all came from things that used to be alive.
I think sugar was once part of sugar cane. It's just been very processed. Seems like most of the food we eat was a plant. We can't recognize it as a plant now, but most of it seems to be. What about the package?
Definitely not compostable.
What about this package?
That does look compostable.
Yep, everything but the sticker. I don't see the sticker in that picture. What about the food without the plate?
Yes, all compostable because it all used to be alive. Yes, compostable.
Bounds. What about this hairbrush? It's a boar's hairbrush.
Oh, boar's hair, then it's all compostable.
There you go. As long as the wood is like chipped. What about receipt paper?
I'm gonna say compostable.
Yeah, probably is. I hear a lot of back and forth on this one because people say how toxic it is. What about gift wrap?
Definitely not compostable
Why not?
because it's made out of plastic. It's not made out of paper.
Yeah, a lot of those bows and the handles on the bags are made out of woven plastic. What about this?
That all looks compostable.
Woohoo! There are alternatives. Okay, so you won the sticker.
Yay.
Congratulations. I'm going to mail you this sticker.
No way.
It's a compost sticker. So my presentation is called, well, the thesis of this presentation is compost and plants lead to healthy soil, which leads to healthy environments and people. Okay, so the first one, I want you to repeat. What's the thesis of this talk?
Compost and plants.
Lead to,
Healthy soil
uh-huh.
leads to healthy environments and people.
Yay! Okay, so that is the main point of this whole talk. Okay, so we're going to start on the first half. Compost and plants lead to healthy soil. Okay, so if you use compost and you spread it on the ground and you put plants into it and the plants are growing, you will make nutrients available at rates that plants require. So the compost feeds the plants. You will, number two, retain nutrients. So your nutrients will not run off or leach. I don't know if you've ever heard of like runoff into lakes or the Salton Sea, how it's destroyed because of all the farm runoff. Farm runoff is a bunch of synthetic chemicals. It's not compost, it's synthetic fertilizers that leach out of the soil and run off into our watersheds. So compost will not do that. Number three, compost suppresses disease. Number four, it builds structure in soil, which it holds soil in place, but it helps it absorb more water. And number five, it decomposes toxins. If you have enough fungi in your soil, it's being used in Japan, and fungi is being used at Chernobyl to decompose toxins there. Okay, so that was a lot. So I don't expect you to remember any of that, but just kind of introducing everything to you before we get into it. Here's the beginning. What are the components of healthy soil that you would use to grow food? So here's the pie, and it shows you the different percentages. What is soil made of?
Is it made of like leaves and biomass and stuff like that?
Yep, and that's going to be the little piece of the pie.
Oh, sand.
Sand, yep, that's another one. So I'm just gonna put that here, sand, silt, and clay.
Um,
45%, and then the little piece of the pie, 5% is organic matter. And then what do you think these other two are?
um, like igneous rock.
Oh yeah, that would be part of sand, silt, and clay.
Then I just have no idea.
Okay, let's go. Here we
Oh,
go.
air and water. Dang.
Good soil actually has a lot of air pockets in it. Half of it is air and water. Healthy soil is full of life. It's high in organic matter, like you said, all the living and dead things, the leaves, and it's full of nutrients and has good structure caused by the air and water. According to the University of California Cooperative Extension, this is going to be a mouthful. Compost is biologically active material that results from microbial decomposition of organic matter. So biologically active means that it's alive. It results from microbial decomposition. So bacteria breaks it down. Just like anything, you throw a banana in the street, it doesn't just decompose from the sun. There's something eating it and turning it into soil. And then organic matter is anything that was once alive. Controlled conditions means somebody's tinkering with it. So that's the difference between compost and a forest floor. In a forest, we have like leaves and animals and poop falling to the ground and decomposing. But when we're making compost, humans are trying to mimic the soil conditions of the forest floor, which is microbes, like a microbial rich compost, or in the forest, it's a decomposed material, but they're both organic matter. And from the last slide, soil is 5% organic matter at least. The key players who are in the forest soil and in your compost pile who break down the food scraps are fungi, bacteria, and all the predators up the food chain. So this is called the soil food web. This is an example of a single-celled organism that is very much like the fungi or bacteria that is breaking down your food scraps. This is just one aspect of a complex ecosystem as vast as the stars in the sky. When we use compost as a soil amendment, plants and my trees take in nutrients through their leaves. They suck in carbon dioxide and they use the power of the sun and also water to create carbohydrates. And when we eat plants, when you eat some broccoli, you're eating carbohydrates. So plants are made of carbohydrates. But what we don't usually hear is that actually plants use half of their carbohydrates to energize themselves and their roots. And then the rest of their carbohydrates, they just leak out of their roots like a slow dripping tap. And what they're doing is they're attracting microbes to their roots, because plants, they can't get all their nutrients from the soil. They actually need to do an exchange with microbes. There's like an underground marketplace going on in the soil where plants are giving away their exudates, also known as sugars or carbohydrates. And then fungi are giving water and minerals to the plants. So plants get nutrients also from their own leaves dropping and bacteria breaking those down as well. The one funny thing about bacteria and fungi is that they tend to stick themselves to the surfaces that they're eating, and that includes the sand, silt, and clay that they're mining. Well, when they glue themselves to soil particles, little particles of silt or sand or clay are now, because they're sticky from the glue, are sticking together. So you're getting all these pore spaces, and so water and air are able to be held in the soil. This is a structured soil, and structured soils behave like sponges. They hold water and they don't let it go away. But if you have a compacted soil, you'll see like on the left, when it rains, water just builds up and it actually just skims right across the soil, and it takes any of the loose soil on top with it. And also the water doesn't stay absorbed in the soil, and then your soil is just really dry. Now, a quick aside, we need to also give credit to the larger organisms who play a role here. And these are also ones you can expect to see in your compost pile as well. In this picture, we have more of a healthy soil on the left, and then we have the lighter soil, which is a more unhealthy soil. And these are both from the same property. They're just taken from two different areas where the soil was amended and one where it wasn't. The healthy soil, it has at least 5% organic matter, maybe 10, maybe 15%. It's got all those pores, it holds the water. It has an array of microorganisms. Now, dirt, on the other hand, it contains very little organic matter. It can be hydrophobic. So if I put a dropper of water and hit the dirt with it, the water actually might roll off of the dirt. Or if it does absorb into the dirt, then it could form very hard dirt clods. Otherwise, the dirt might just blow away in the dust. The only organisms you'll see in dirt are bacteria, and you'll see root-feeding nematode species. Okay, so here's your turn. Here's your practice. How do microbes build healthy soil?
They help keep the soil from washing away and prevent desertification.
Yep. Yep. And why are plants an important part of the equation?
Because they help create biodiversity.
That's true. Also, if the plants weren't there, what would the microbes eat?
That's true. They wouldn't have anything to eat.
So it's like the plants need the microbes, but the microbes also need the plants. And yeah, so it's like a mutually beneficial relationship. I'm just going to give a quick caveat for this presentation. All the benefits I'm referring to apply to two types of composting, and that would be thermophilic composting, which is hot composting, where your compost pile gets between 131 and 150 degrees for 3 full days. And you also have high oxygen. And I'm also referring to vermicompost, which vermi means worm in Latin. So worms need to be at human temperatures. It also have to be oxygenated, and all parts of the compost must be in contact with the worm for this to work, because worm skin is covered in beneficial microbes that reduce pathogens. The types of composting this presentation doesn't really refer to, possibly, is bokashi and anaerobic digestion. I don't know enough about those yet. So, second part of the presentation is healthy soils are an important component of environmental health. So, compost can increase the nutrient density of plant leaves and fruits, and it can increase crop yields, and it can improve plant immune systems, just like you have an immune system, plants do too, and also create good habitat for other organisms. So I'm going to start with this very confusing chart, but basically what it shows is all the bars represent biomass of plants, so plant growth. And if you put a plant seed in just plain sand, silt, and clay and organic matter with no microorganisms, your plant will grow, but it won't grow very much. As you add more microorganisms, you add bacteria, it will grow a little bit more. As you add other microorganisms, bacteria, protozoa, and bacterial feeding nematodes, you get a little bit more plant growth. And then as you add plants, bacteria, protozoa, and fungi, you get the best plant growth. And then there's other combinations as well. So basically, microorganisms positively impact plant growth, which makes sense because if you remember, plants feed microorganisms, and microorganisms feed plants in an underground marketplace. But there's more. Okay, so the picture you're seeing is a microscopic view of a leaf. And the leaf is covered in bacterial glues and fungal hyphae. Fungal hyphae is basically kind of like the roots of mushrooms. Okay, and so why are all these bacterial glues and fungal hyphae on the surface of the plant leaf? Not only because bacteria is everywhere, plants release sugar from their leaves to attract fungi and bacteria, because if their leaves are covered with beneficial bacteria, then there's no room for pathogenic bacteria to land on the leaf. And if it even does, some of the good bacteria or good fungi will eat it. That's another benefit of compost, is that it has this good bacteria that protects your plants from pests and diseases. Soil microorganisms are like a suit of armor. What else? Soil structure creates a sponge effect in the soil. Plants, if they have a structured soil, they're more likely to hold water and air better. Why do plant pots have holes in the bottom? Plant roots need a balance of moisture and air. And if they don't have a balance of moisture and air, this is what your soil will look like. So this soil is not well structured, and your plant will drown and will probably die. So in addition to drainage, the pore spaces make the soil more loose and easier for plant roots to grow through. And when plants can grow their roots as long as they want to, they actually grow them a lot deeper than what we think. Let's do some practice. How do microorganisms in compost support plant health?
Um, they support plant health by attracting the fungus.
They do. And the fungus is like a suit of armor, right?
Yes.
Yeah. Yep. Healthy soil promotes a healthy environment. When soil is wet and when it's all glued together, it's less likely to blow away like dust. We're losing a lot of topsoil right now because we're killing microorganisms in the soil. Compost, though, would help with this type of problem, or a compost tea. Soils without organic matter and microorganisms become compacted and they do not hold water well. Instead, water skims off the surface, pulling any loose dirt along with it, stripping topsoils. This contributes to flooding, and it also throws off water cycles and contributes to the more erratic weather patterns as well. Healthy soils with their high water holding capacity, with roots in the soil to help maintain the soil sponge, they maintain small water cycles. The more plants we have in the ground, the more likely we are to keep water and not desertify the land we're living in. In California, we're making efforts to offset our greenhouse gas emissions by planting trees because they sequester carbon. But are we joining the forces of soil and trees together? Compost helps sequester carbon in the soil. And the plants are required because they're pumping the carbon out of the atmosphere. But as they leak carbon into the soil, it's staying there. Research across the world, including presented at the Paris Climate Summit in 2015, the Marin Carbon Project in California, and Project Drawdown, all suggest that spreading compost is one of a very important way to increase carbon sequestration to reduce the effects of global warming. In Climate Action Corps, we focused on making the compost to reduce methane emissions, but we didn't focus on what are we using our compost for. And if you combine all your tree planting with your compost, you'll be sequestering even more carbon. I want you to list some specific examples of how soil amended with compost supports a resilient environment.
Well, it helps prevent the Dust Bowl.
Yep, that's a great one. In this last portion of the presentation, I want to give you the opportunity to practice answering these questions in your own words. So the first one is, what's the difference between compost and soil? So pause here and then listen for my response. The difference between compost and soil. We learned that compost is 100% organic matter. In one of the first few slides, compost is organic material, banana peels, leaves, logs that have been turned into wood chips, and it's been mixed together and it has decomposed. So soil is what you find on the ground, and it's a mixture of organic matter and sand, silt, and clay, as well as air and water. Air and water is also inorganic matter, though. What causes the compost pile to get hot? A lot of people will say they think the sun causes the compost pile to get hot, but the main thing is that You're having a lot of chemical reactions and physical breakdown in your pile. When you mix the greens and the browns and the air and the water, the microbes are breaking that material down. And you can imagine as they use their enzymes and other molecules in their bodies to break down the organic material into something new, there's going to be a lot of heat generated. Most of the heat is generated by the bacteria. If your pile gets too hot, you have too many bacterial foods in your pile, and that your pile should have more woody materials so that it doesn't get so hot. Why are you making compost when you can buy it from the store? That's because what is the benefit of compost? It's microbes. Microbes have their niches and they have their microclimates and general climates that they live in. And so the microbes that are going to perform best with your plants in your climate are going to be on the surfaces of the plants that are growing in your yard. And then you heat treat them to kill pathogens, or you put them through a worm bin to kill pathogens, and you have something that already can survive and thrive in your area. And that's why you want to make your own compost as opposed to buying a bag of compost from the store that came from across the country somewhere. I thought plants make their food through photosynthesis. What is the role of soil? Just like you and me, plants cannot live on carbs alone. They also need some vitamins and minerals. How do I know when the compost is finished and safe to use? If the compost smells good, like a forest floor, it's safe to use. If it's very stinky, the nose knows it's anaerobic. Or even if it's kind of stinky, it might be a little bit anaerobic. Compost at first, if you're using animal manures while you're turning it and the manure has not broken down yet, yeah, it's going to smell like whatever poop you're using. But after it's been sitting, it shouldn't have that smell. And so that smell is an indicator. It might not mean there's human pathogens in your compost, but it's the same conditions that they thrive in. So you're taking a chance. So wash your hands. So ambient temperature, the smell, and the crumble, like kind of like coffee grounds. How do I avoid bugs and pests in my compost pile? I just tell people nature has bugs in it, and they do belong in decomposing material. If you keep the greens buried under browns, you're going to have a lot less flying bugs flying at you. The type of bin you use might keep critters out. I used one called the worm wigwam that was supposed to deter pests and keep them out. That was for the worm bin. I used the geo bin for my hot thermophilic compost piles, and rats don't really get through that very well because it's plastic and it has very small holes. If your pile's hot, you're less likely to have a heck of a lot of bugs or rats. True or false? The process of composting releases CO2 into the atmosphere. So the answer is it's true. Composting does release carbon dioxide into the atmosphere. So you might think, well, I thought we were trying to reduce emissions. And we're trying to keep our food scraps out of the landfill and compost them so we don't release methane, but we're releasing carbon dioxide. Well, one, methane is more potent than carbon dioxide, right? Even though carbon dioxide is more long-living. But yes, anytime anything decomposes aerobically, probably releases CO2, and even we release CO2. Also, this is a good reason to create fungally dominated compost because the main decomposers in the soil are bacteria and fungi, remember. And if you have a lot of fungi in your soil, they release a lot less CO2 than bacteria do. So bacteria blow off about 80% of the carbon that they consume, and they blow it off as CO2. That's their waste product. They don't really poop, they fart out CO2 kind of. Well, fungi only release 20% of the carbon they consume. So as they're breaking stuff down, they're actually storing the carbon in their bodies. So a fungally dominated compost, if you can make it, will be better for your trees anyway. That's the compost they want to live in. And then that will sequester even more carbon. So that is my basic final message to you, that compost is good for soil, it's good for plants, and it's good for people and the environment. And if we can make a fungally dominated compost, that would be the thing we should do. From a climate perspective, compost is a triple win. It increases the sequestration or the drawdown of atmospheric carbon into the soil. It mitigates emissions from other sources like landfilling or burning. And it enhances the land's resilience to extreme weather like flooding and drought. Thank you so much. And please make some fungally dominated compost.